Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover WolfGuard FIPS 140-3 enabled WireGuard, presented by Software Engineer Lealem. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. After the presentation, Lealem will answer your questions. As always, our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on X, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to contact us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 5 billion connections. We have more than 2,700 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification, and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfBoot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full-service consulting. Now I'd like to turn it over to Lealem to discuss WolfGuard FIPS 140-3 enabled WireGuard.
Thank you, Emma. Hi, everyone, and thank you for choosing to spend your morning with Emma and I and wolfSSL. So we are talking about WolfGuard today. This is our FIPS 140-3 enabled WireGuard, and I'll just touch on our motivations here. The WireGuard project's been gaining popularity over the last decade or so, and as it's seeing more use in more and more areas, what people are starting to see is that when FIPS 140-3 cryptography is a requirement, with any dealings with the government, then standard WireGuard is not an option for reasons that I'll go into further. But there's a real need for the functionality that WireGuard provides while also ticking that FIPS checkbox. And WolfGuard is wolfSSL's way to address this need. So in case you're not that familiar with wolfSSL, I'll start off with a quick intro. We've been around since 2004. We're a software company, and our goal first and foremost is to secure the internet by securing data. And that's, regardless of the vertical, we're in everything from aviation and automotive to printers and appliances. And like Emma mentioned, we secure, at any given point, we estimate more than 5 billion connections, which I think is a pretty cool stat. So our company focus, securing data at rest, securing data in transit, and then securing firmware updates or the boot process. For data at rest, we have our cryptographic engine called wolfCrypt. For data in transit, we have wolfSSL, which provides SSL TLS and DTLS. And we also have implementations for SSH and MQTT. And then for secure boot, we can do the cryptography there with wolfCrypt as well. And we also have a secure bootloader called wolfBoot. And I mentioned these two on the top left here, wolfSSL and wolfCrypt. These are our flagship products. They're both C libraries. wolfSSL is our clean room implementation for SSL TLS. And it's embedded is a focus of ours, so it's highly optimized for size and speed. wolfCrypt, this is our cryptographic engine. Same story there. It's optimized for speed, optimized for size, and this is where our FIPS certification lives. So the other cool thing that we do here is we take our code and take it through different certifications so that our users can leverage us where they otherwise couldn't. So FIPS is, of course, for federal agencies. If you're dealing with the government, we've had several certifications for FIPS under 140-2. we have 2 active certificates for FIPS 140-3 and have 2 more on the way, or 3 more at this point. And then we also have DO 178 certification, and that's specific to the aviation industry. And then MQTT, SSH, these are those protocols that I mentioned. These 2 are worth highlighting as well, Wolf Engine and Wolf Provider. What these 2 products allow us to do is to take any existing OpenSSL application and reroute the cryptography there to wolfCrypt, so to our cryptographic engine. And the main use case there is obviously FIPS. So basically, you flip a switch and your OpenSSL app is using our FIPS cryptography. And then at the bottom here, we've got a few language wrappers and bindings that we offer. We want to make sure that our C libraries are accessible to our users, regardless of what they're using. WolfClue is another cool project. It's our command line utility, and it lets you perform cryptographic operations or certificate operations from the command line. So with all those products that I mentioned, wolfSSL and wolfCrypt especially, we have an active commitment to enabling other open source projects with our technology. And that's in order to let them benefit from our TLS, our crypto, our performance, of course, our FIPS certification, basically everything that we put our hard work into, we want to make that as accessible as possible. So we have this OSP repository at this link here, and that's where we host a lot of the drop-in ports that we do for widely used open source software. And one more thing that I wanted to highlight here was one of our latest products, full Linux FIPS. And what that is a way to run FIPS cryptography in an entire Linux distribution. So regardless of what apps are in your Linux distro and what crypto providers they may be using, whether it's kernel cryptography or OpenSSL or GNU TLS, we have the technology to reroute all of those crypto calls to our cryptographic module, which is FIPS validated. So that kind of highlights one of the things that we do best, and that's taking something that isn't FIPS enabled and making it FIPS enabled. And that's essentially exactly what we do with WireGuard and WolfGuard. So I'll start talking about WireGuard here, a few intro points. WireGuard is a modern VPN protocol. It was released in 2015, so within the last decade, it's newer, and it was developed by Jason A. Donenfeld. WireGuard is also the name of the open source implementation of said protocol, and it was designed to be a simpler, faster, and smaller VPN. There's just no bloat there. It's nimble, it's direct, it's fast, and it works great. Obviously, it's secure by virtually, or at least partially, because the attack surface is so minimal. And that has to do with the fact that the WireGuard protocol is based on the noise protocol framework. And the noise protocol framework is a essentially formula for creating secure protocols. And several other high-profile projects use noise, but WireGuard was an early and significant adopter. So we talked a little bit about the protocol. These are some popular implementations of that protocol. WireGuard Linux, this is the reference implementation. It's the foundational code base that Jason Donenfeld worked on. And this is the kernel space implementation. It's written in C and comes with all the benefits that operating in kernel space provides. And this project actually made it into the Linux kernel about 5 years ago, so that's pretty cool. And then WireGuard Go, this is the official user space implementation. It's written in Go or Golang. And because there is no Linux kernel dependency here, it's able to run cross-platform. And so it's leveraged under the hood in in WireGuard Windows, WireGuard Apple, and WireGuard Android. WireGuard Android can use either WireGuard Go or WireGuard Linux because Android under the hood is Linux, right? So you have your options there. And the last one that I'll mention, BoringTun. This is Cloudflare's implementation of WireGuard in Rust. They chose Rust over Go, citing a few things. It was performance. They had issues with some of the Go routines. They also wanted better direct-to-system interfacing. Overall, they thought Rust was the language for the job for a user-space WireGuard. And this is a popular project. So with Cloudflare alone, it's deployed on millions of iOS and Android devices, and that's on the Cloudflare client side, and then it's on the Cloudflare servers as well. So a quick overview on how WireGuard creates secure VPN connections. First step is to generate cryptographic keys on your two endpoints. Next, a WireGuard handshake happens using those generated keys, and a secure tunnel is established. And at that point, any data that you send from one endpoint to the other through the tunnel is encrypted and then decrypted at its destination. And it gets efficiently routed. You're assigned a static IP address within your network so that any changes to your physical IP bears no consequence. And then you're automatically reconnected if any changes to your network happen because of how WireGuard and noise work. So if your network drops and then you regain it, or you go from cellular to Wi-Fi, it'll reconnect manually without any manual intervention. So WireGuard is awesome. Let's say you have it working in your product or system or sysadmin stuff. Either way, what happens when you come across a FIPS 140-3 requirement in your dealings with the government? So that could be a direct FIPS 140-3 requirement. It could be through FedRAMP if you're if you're a company that provides cloud services to a federal agency, or it could be CMMC 2.0 if you're a government contractor or subcontractor that handles any CUI or controlled unclassified information. So with all of these, you're going to have FIPS 140-3 cryptography. And like I mentioned earlier, WireGuard, or at least the standard WireGuard, won't work here. And this is because, well, not only are the cryptographic implementations that WireGuard uses not FIPS-certified, the algorithms in use there are not FIPS-approved in the first place. And so if your customer is asking you about FIPS cryptography, that won't swing. So what are your options here? The answer used to be you have none. The answer now is WolfGuard. So I'll talk a little bit about how we bring FIPS into WireGuard next with WolfGuard. So you see on the left here, these are all the algorithms that WireGuard natively uses. So for key agreement, for example, it uses curve 25519. For hashing, it uses Blake2S. And for the cipher, it uses Cha-Cha-Poly. These algorithms are not FIPS approved. There are questions on if they will ever be FIPS approved. So what we do is we go through the code and redirect the crypto calls to our FIPS-certified library with their algorithm equivalents. So for curve 25519, for a key agreement, for example, we use ECC P56, and this is a NIST-approved curve. And then for Blake2S, we go with the NIST-approved SHA-256, and the list goes on. And what happens here is you're left with a WireGuard build that not only uses NIST-approved and FIPS-approved algorithms, you actually use a FIPS-certified version of those algorithms with wolfCrypt. And if your requirement is FIPS validation, wolfSSL offers that as a service as well. And that's essentially taking your OE or your operating environment and getting that added onto our FIPS certificate And what that will leave you with is a FIPS validation. And that's essentially all that WolfGuard is. So a few points here. WolfGuard is as easy to use as WireGuard. There are no architectural or usage changes. So I'll go back one slide here. All we're doing here is redirecting the crypto. We leave all of the VPN code to WireGuard. That is their specialty. Our specialty is cryptography, and that is what our contribution here is. Second, WolfGuard coexists and can coexist with WireGuard. So if you have to have both tunnels running on an endpoint for some reason, or if because that's the other thing I should mention actually, these two don't interoperate. So when we do the port from WireGuard to WolfGuard, we're switching the internal crypto primitives so that WireGuard and WolfGuard can no longer speak the same language, essentially. So because the two can't interoperate, if you don't want to lose your endpoint, you're going to have some sort of transitionary period where you have both running, and then eventually you can just have WolfGuard as your FIPS endpoint. This is the main point here. WolfGuard uses the FIPS-certified wolfCrypt as its crypto backend, and you can actually end up with a performance boost with hardware acceleration. So the algorithms here that we chose for hashing, for example, SHA-256 and then AES-GCM-256, you're going to be able to accelerate those in hardware, whether you're on ARM, on Intel, on AMD. wolfCrypt's got the ability to accelerate those algorithms in hardware. WolfGuard Linux, this is our FIPS crypto integrated version of WireGuard Linux. And so WireGuard Linux operates in kernel space. So we actually use our kernel module. So wolfSSL as a library can also be built as a kernel module. And that's what we leverage to access our wolfCrypt module from WolfGuard Linux. And then WolfGuard Go, again, is the FIPS crypto integrated version of WireGuard Go. And to access wolfCrypt from WolfGuard Go, we use our Go wrapper, Go wolfSSL. So WolfGuard Go calls the Go wrapper. The Go wrapper reaches down and calls our C wolfCrypt code. And I'll give you a couple examples of real world applications we've seen WolfGuard in. We had a customer that already had a tunneling service that they provided as a product, and they came across, they had a deal cook in, they came across a FedRAMP requirement, and they couldn't get WireGuard. They couldn't sneak that in, right, with FIPS 140-3 cryptography as a requirement. So they reached out to us. We got them up and running on Red Hat Enterprise Linux 9.6 for WolfGuard Linux. And then on Windows 11, they're using WolfGuard Go, and they're shipping that out to production pretty soon here. Another customer had WireGuard set up to access their endpoints. They came across a CMMC 2.0 requirement, and through WireGuard, they were sharing CUI, or controlled unclassified information. So their cryptography there had to be FIPS. And so what happened was they reached out to us also. They got it up and running in a week. It was really easy to use because from their side of things, nothing had changed. They're just using this new version of, they already knew how to use WireGuard Go, so WolfGuard Go is super easy. And I wanted to show you how easy setting up WolfGuard Go is actually. So quick demo here. I'll just exit out and open up a new browser here and search for OSP wolfSSL. And that actually took me to the page. Essentially, at that link that I showed earlier, we can go down to this WireGuard Go directory right here. And we see that we have two patches, WireGuard Go FIPS, and then just WireGuard Go wolfCrypt. We can follow these instructions, and that's exactly what we're going to do. So what we're concerned with today is the WireGuard Go FIPS patch. This patch just reroutes all of WireGuard Go's crypto to wolfCrypt without switching out the cryptographic algorithms. But this is what we're interested in showing today. So I'll put this on here, minimize that, and get a terminal up and running. Okay. So I'll make a directory here, call it WireGuard Go demo. That's not it. So we're just going to follow these instructions. First step is to build and install wolfSSL and Go wolfSSL using the instructions. Here I Go wolfSSL at the README there, so I'm just going to open that up. And to use the wolfSSL Go module, we see that we have to clone the wolfSSL repo, install it to our system. So I'll do that first. So I'll git clone wolfSSL, and I'll just specify this depth 1 to get the most recent commit and make this go faster. And we just pull down the wolfSSL library. So this houses wolfCrypt internally. So we'll go into that directory and follow along here. We run autogen to generate our configure script. And next up is to run the configure command. What this will do is build it with all our standard settings. But we see here that when we're interested in the FIPS build, we want these settings here. I'm actually just testing with the mainline GitHub version of wolfSSL. Our FIPS-certified code is available upon licensing. So we'll just copy that there and remove the FIPS-specific flag. Enter. And then we'll build the library with the make command. And lastly, I'll just install to my system. Okay, so now we have wolfSSL set up and installed. To set up our Go wrapper, Go wolfSSL, we'll go in and clone that repository. And that's done, so we'll go in there. And we have to run this generate options shell script and point it at the directory where wolfSSL is housed. So wolfSSL is housed one directory above, right there. And what this does is generates an options.go file to keep the Go wolfSSL and wolfSSL builds in sync. So we've just set up Go wolfSSL here. And next up, we are going to clone WireGuard Go. So I'll just grab that link there. Go back out. We have Go wolfSSL and wolfSSL installed so far. And here I clone WireGuard Go. And to build WireGuard Go, all you run is make, right? And there it is, WireGuard Go right there. So if I run sudo WireGuard Go -f, and then so F to say run it on a foreground, and then I'll call it U109 because I'm running on a Mac here. And then if I run it, that's all it takes to run WireGuard Go, right? I'm going to show you how simple it is to get WolfGuard Go up and running. So I'll say make clean here. And I'll go back to our instructions where we're patching WolfGuard. And we see here that these patches were specific to this or WireGuard Go commit. So I'll just copy that there and check out to that commit where we tested the patches. And now that we're there, all we have to do is go into this WireGuard directory, WireGuard Go directory, which we already are, and then apply this patch here. So this WireGuard Go FIPS patch. So what I'll do is open up this file here, and I'll just copy the entire file. Once that copy, I will open up a file. I'll call it FIPS WireGuard .patch. And then I'll just paste the contents here. And I'll save that. Let's go back to the instructions. And they just tell us to patch WireGuard Go with the new patch that we just created. So I'll call it, I'll type in patch P1, and we call it FIPS_WireGuard patch. I'll press enter here. Okay. So we've patched WireGuard Go to become WolfGuard Go now. And all we have to do is install Go wolfSSL into this project. So we're at the WireGuard Go project directory. We're going to copy our command to load the wolfSSL module in for Go. We just added it. And then now what we're going to do is edit the mod file so that it's pointing at our local Go wolfSSL instead of the one on GitHub. So I'll just go out here, go into Go wolfSSL, and grab the current working directory. We'll go back out into WireGuard Go, and I'll copy over my command here and point it to my local Go wolfSSL, which I just copied, and press enter. And that should be it. Now, if you run the unit tests, we can go into device and then run go test. We just ran the unit tests on a fully FIPS-certified version of WireGuard Go and see that they're all working. And as far as usability goes, it's literally all the same. So earlier we did make, so we'll do the same make again. And we see WolfGuard Go here. And if I run that in the foreground, of course, I've got to give it a name, WolfTun 9. And just like that, the WireGuard that is running currently is actually WolfGuard, and it is a fully FIPS cryptographically approved module that it's using. So I'll cancel out here and bring the presentation back. And so you guys, I don't know how long that was, but it took barely 10 minutes, maybe less, to set all of that up. Hopefully less. So now that I've kind of spoke about that part, I wanted to talk about maybe future items that we could look into next. BoringTun, this is incoming. This is going to be our FIPS integration of BoringTun, or our implementation of WolfGuard, in the Rust implementation of user space WireGuard. We also want to integrate WolfGuard into Tailscale and Headscale so that people can leverage those with FIPS cryptography. And then lastly, post-quantum cryptography enablement in WolfGuard. So the CNSA 2.0 guidelines specify that ML-Chem 1024 is a requirement. So we'll be able to do that and get you guys CNSA 2.0 compliance pretty soon, shortly here. Okay, at this point, I'd like to turn it over back to Emma to answer any questions.
All right. Well, thank you, Lealem. To start off the questions, how complex is the transition to WolfGuard?
So it's actually extremely easy. You guys saw how simple it was to transition the build from one to the other. As far as transitioning in usage on your side of things, there's literally no change. It's all the command line. It's all the same command line arguments. It's all the same, uh, you know, patterns and repeated. Your scripts don't have to change anything there. All you have to do is change that wire to wolf, and then you're all set to go. So not complex at all.
Wonderful. How do you ensure that only FIPS-approved algorithms and modes are used during operation?
So the way we address that is when we change the code, we completely remove the capacity to call non-FIPS approved algorithms. So we ensure it by completely removing any other references to cryptographic algorithms that aren't directly those four algorithms that I had shown on the screen earlier.
Wonderful. Is it possible to use keys created within a secure element?
Yeah, if your secure element is creating ECC P56 keys and they're completely, valid, if they're real ECC 56 keys, we can definitely consume those.
Awesome. What is WolfGuard's performance compared to WireGuard?
So I mentioned earlier um, that we can accelerate the crypto in the algorithms that we've used. So you could end up with a faster WolfGuard than WireGuard, but in general, so WireGuard with and without the cryptography, so standard WireGuard with cryptography, and then WireGuard with no cryptography, the delta there is only 5%. So the deltas between WolfGuard, WireGuard, either way, are not going to be significant.
Okay. Well, thank you, Lealem, for hosting an informative webinar. Thank you to everyone for joining. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at facts@wolfSSL.com. Thank you again, and we look forward to seeing you on September 4th for our webinar on post-quantum curl, future-proof your data transfers. Thank you all.